Und wir dachten so, ja, vielleicht ein Filmsport, weil
also für den Sport.
Ich weiß nicht, ob ihr dieses
So we are here, right? I mean, like basically what we did last week and the week before, I think, right? Was to derive the new Keynesian model, right? I mean, you see the title, right? I call it the inflation monetary policy. That's how I motivated the whole story, right? We actually want to talk a bit about inflation. And that's what I'm going to do today, right? I'm going to use the new Keynesian model and look at inflation through the lens of the new Keynesian model and show you some of these important things that we think about, right? So we've done a lot, right? I mean, just to maybe to remind you, we're basically here, right? I showed you last week all this firm side derivation of the new Keynesian model, right? And maybe to remind you, I think that one of the most important slides here probably is that one, right? This here gives you the new Keynesian model in its most stripped down version, right? And I mean, what is nice about this model, and I mean, I think this is the reason why we like use it a lot and also teach it a lot. You have like these three equations, and these three equations have a very straightforward interpretation, right? What is the Euler equation? How do we integrate this? This is actually nice about the new Keynesian model, right? I mean, you also do all this math. You have to go through all these equations. I showed you this, right? But in the end, you have kind of this compact form. So where did we derive the Euler equation? Where does it come from? You wrote down some kind of maximization, right? And at some point, we ended up at the Euler equation. So who's maximizing for the Euler equation? Not a good day to be asking questions. Households, right? So what does the Euler equation represent in my economy? Yeah. And what do households do? Maybe that's the way to say it.
They decide about investment and savings
and consumption, right? So this is demand, right? That's where I want to go, right? The Euler equation, this is like in these new Keynesian type of models where we consider aggregate demand. This is demand, right? So like all these kind of, if you have these kind of Keynesian ideas in mind that demand plays a role in these models, this is the Euler equation. This is what's coming. Right? I mean, this looks maybe a bit abstract, right? But I mean, remember when we talked about the Euler equation, I mean, I didn't do this in this chapter because we basically did all of that before, right? Which is true. this here is the interest rate, right? And I mean, we talked about in the RBC chapter, we talked about all these different channels that come in, right? How households adjust their consumption, saving, whatever, right? But here you have this very simple mechanism, right? If the interest rate goes up, people will save more, they will consume less. So you have a direct effect on the market. And then I spent some time last week talking about what I call here, this is the interest rate, so think of this as the webinar, and it's all this what I call the NKPC here. What's that? Exactly, right? And if the other equation is 1, right? And I mean, I hope this also kind of makes sense, right? I mean, you derive this from the firm problem. This is firms, this is who's actually producing something in this economy, right? And then the households are eating that, right? That's the way how we think about the economy, right? I mean, we already spent some time talking about this new Keynesian policy curve last week, right? I mean, but it has this very clear message, right? Inflation today, and I mean, the new Keynesian model works in terms of inflation, right? The price level per se is not so interesting. Right, on to the different models, which are more about the price level. Here's all about inflation, right? But inflation, that's prices changing, right? So this is prices, right? So the change in prices, inflation depends on the expectations about future inflation, and it depends on your current output gap. And that was basically what we were discussing last week when I said, okay, this here predicts if we are in a recession, the output gap is negative, you will have lower inflation, right? Whereas in a boom, you will get higher inflation. And the last equation is the Taylor rule. What's that? Right, that's this idea of what's the central bank actually doing here, right? So the way to say that this is policy, right? So if you strip down the model in terms of households, demand, firms, supply, and this here is policy. Okay, now you can use the model to do all kind of things, right? So we basically already discussed this last week, right? I kind of hopefully explained a bit why we call this a Phillips curve here. Now I want to use this, as I just promised, to talk about inflation, right? So where does inflation actually come from? What is the inflation? This is actually not an too easy question, right? And I mean, you also sometimes get different answers, right? I mean, for example, during like the recent inflation period that we've seen, there's also been with different papers, which suddenly propose very different understandings of inflation, right? And I mean, we can have very different theories. Let's see the quantitative theory of inflation. You've seen the quantitative theory of inflation. So what's this, right? This classical idea of what's driving inflation. Like if I were to ask you, right? You're studying economics. What's driving inflation? What would you know?
The amount of money.
That's the point, right? So that's like the monetarism idea. What's driving inflation? In the long run, it's all about quantitative money that we have in the economy. It's about money supply, right? So that's this famous equation where you basically say, okay, in the long run, prices change because M changes, because money supply changes. That's what we like. That's what's typically the first thing that we like in a money value and say about this. But we also typically also say that in the short run, this can be very different. This is one of the models where in the short run, this is like, right? I mean, yeah, again, I mean, what else would you say is driving inflation?
Output gap and expectation.
I mean, that's the new Keynesian Phillips curve, right? Exactly, right? That's what the new Keynesian Phillips curve will tell us is driving inflation, right? It's where your current economy is, where you are in the business cycle, that's inflation.
Like supply side and inflation, for example, like during the inflation supply
self-fulfilling story, right? I mean, once inflation picks up, then inflation really picks up, right? It's a bit like a pathway, right? For that. Here's a bit in here, right? Because also you have, if inflation expectations go up, also inflation will go up.
Maybe also wage setting regimes. So if the unions are really powerful, they set
right. So I mean, if you make a deflation, right? I mean, deflation is about firms, right, getting profits because of that increase in prices. Worker getting profits, right? That would be wage increases. So it could also drive inflation, right? I mean, these are like these typical candidates, right? We probably forgot many. I think that would be like the most. I mean, this is a very classic question in macro, right? What's actually driving inflation? Because, I mean, also for a central bank, if you want to calculate inflation, that's what you should understand. Right? And I mean, this is also why this model is so important for actually want to cause. Okay, so now let me show you a bit what this model implies. And then some of the stuff we basically all been saying, right? Here, this is a dynamic model, right? Always means that some of the stuff may be a bit hidden here, right? But what we can nicely do, and maybe for that I should actually start here again, right? Here you have that inflation depends on inflation and performance and expectations about inflation, right? But what you can always do with these equations, and I mean we've also done that before, right? If this equation here holds in t, this equation here also holds in t plus 1, right? So you can write the new Keynesian Phillips curve as, and we have expectations then, right? That inflation expectations in t plus 1 will depend on, and now you will get an ET, expectations about inflation in t plus 2, plus so on and so forth, and here you will have the output gap. Expectations, I believe, about the output gap in t plus 1, right? So if the inflation today depends on tomorrow's inflation will depend on inflation in the period after tomorrow, right? You can make the same argument for t plus 2 inflation, that will depend on t plus 3 inflation, and so on and so forth, right? So that's what I would say, that this is like this iterative stuff here, or you're writing stuff in the recursive form, right? Because I mean, if you define this for t, this goes for everything. Alright, so now this is what I'm using here. So basically all I do now to end up in equation 7, I think it's the important one. All I do to end up at equation 7 is basically use this and insert this here now over here. Right? So then what you get is that pi t plus 1 disappears because that's what you're substituting. What you will get in is a pi t plus 2, and here you get the output gap in t plus 1. And now you continue doing that for the pi t plus 2, and you will then insert expectations in pi t plus 3 plus the output gap in t plus 3. Right? And if you keep doing that, what you will get at some point is this equation. Right? So you see here, this is basically just giving you an infinite sum, which always works happy. But if you do this like substitution long enough, you get basically all these future output gaps. You will also get expectations about like the very, very long run, right? You will have a term say here that you will get expectations about inflation in t plus infinity, right? If you do this long enough. What's the expectation about t plus infinity? Well, I mean, if your central bank is doing a decent job, right, this would be at the target, right? And I mean, here we just say this target, let's say that this is 0, right? So what I do here on the slide is just to say, well, these long run, like these very long run expectations, you just take that at 0, right? This is basically what I have up here. So then you see that the new Keynesian Phillips curve, and I mean, it's the same equation, right? It's just rewritten. that this equation here tells you that the current inflation does not just depend on the current output gap, but it actually depends on expectations about all future output. Right? And this is again one of these powerful predictions of the new Keynesian Phillips curve. Inflation today is not only about what's happening today, but it's actually about expectations about the whole future. Right? And I mean, the model has a story why this is the case. Right? Remember when we wrote down the firm problem, I defined this Calvo idea, and already there I said, I mean, as a firm, you're allowed to adjust the price today, but you know that with a certain probability, you are not allowed to adjust in the future. And because of that, you already think about what's happening in the future, and this will be like part of your current pricing decision. Right? And this is why the current level of prices, reset prices, and because of that, also inflation, depends on all future expectations of the output. What I do here in equation 6, this is not directly shown on the slide, but this output gap is directly related to the marginal cost of production. This comes from basically from the Phillips curve. So this is true, you can show this. So which basically just tells you, right, if the output gap is positive, firms are producing a lot, right? Which puts, think about this, I mean, pressure on their costs, right? The marginal costs go up if you're really producing a lot. And this is in the end what makes them raise prices, right? I mean, your costs go up, so this is what increases prices, right? So this is always this direct matching, right? And very often you see this Phillips curve written in terms of the marginal cost. This is why I have this slide. Okay, you can also think about markups, right? What was the markup?
And if firms have like market power, they can mark up like the competitive prices, some profit margins.
Exactly, right? So this markup was in the model, this epsilon over epsilon minus 1 term. I said, okay, this is like the additional markup that firms had on marginal cost, and which is basically like the wedge, right, between marginal cost and price, right? So to what degree are prices higher than the marginal cost of production, right? So if you want to translate reflation, that's a way to translate reflation, right? So firms are setting higher prices compared to their actually cost of production, right? That's exactly what it means, right? It's a way to put this in a model, right? So in the model here, what is true that these markups will directly relate to these marginal costs. So there's actually an inverse relationship. So you always have the case where marginal costs are high, markups are low, which is by construction, right? Because, I mean, you can only adjust prices like with the sticky nature, which means that if your markups increase, if your marginal costs increase, some firms will increase prices, but not all of them. And for those that cannot increase prices, their markups will go down, right? Like construction, basically, right? So this is also what I said at some point earlier, that in this model, which I actually also think is nice, right? Because it is a model with monopolistic competition. You have profits here in this model, you have markups, right? So this is all moving here. You can actually talk about this, right? So another interpretation of that here is to say, if firms expect that in the future they will not be able to charge high markups, because, for example, that competition is higher, because we're in the boom, whatever, right? They will also adjust their price today, and this is already creating inflation today. Okay? That's another way to interpret it. Okay. So yeah, inflation not only depends about current output gap, but inflation also depends about what you expect about the future path of the economy, right? That's a way to say it. Why does that matter? Well, I mean, our central banks care about that a lot, right? Do you know what forward guidance is? What is forward guidance?
I think it also has to do with the communication strategy of the central banks to, I think it was Mario Draghi in the Euro crisis who said we will do whatever it takes. And just by saying that the interest rate or the spread in the central banks really increase.
Sure. It's also a bit more specific. So forward guidance typically is, and it means forward guidance. So you can basically really translate it, right? So what central banks do that do forward guidance, they're not only communicating about their current policy, but they're also communicating about their forward policy. So they're trying to affect the expectations that, in this case, firms have about how the economy will behave in the future, right? And if Mario Draghi, I mean, this is one of these like typical examples. I mean, if you look at like these policy communications, or I mean, also like Christine Lagarde today, right? They were like under forward guidance. They would say, okay, today we set the interest rate at 1.75 or whatever, right? But we will also keep inflation rates low for whatever period it takes, right? That's going back to the wording that we were just referring to, right? So they're not only communicating about the current inflation rate, but they're also communicating about future inflation. That is forward guidance, right? And you can really read this in, I mean, when that was important under conventional monetary policy, you could really read this in the policy statements of the ECB, right? They were doing that extensively. And the reason why they do this is exactly this, right? If you have a new Keynesian world in mind, people, right, in the central bank acknowledge that if they communicate something about the future path of interest rates, they will basically tell firms something about how these output gaps will behave in the future, right? Basically by saying we keep interest rates low, even if the economy picks up again, but we keep interest rates low nevertheless, that basically tells firms, okay, that allows me then that I can actually, like the output gap will go positive in the future, right? And this then already means as a firm, maybe in the future I cannot adjust my price, but today I can, and that will then generate inflation today, right? That's the inside of that equation 7, right? And this is why forward guidance works, right? So, I mean, you don't necessarily need to like one-to-one believe in the Keynesian model, but basically it tells you that inflation today is also affected by what firms in this case expect about the future path of the economy. And central banks communicate about exactly this, right? And that's what they try to exploit with this forward guidance strategy, right? Does that make sense? So this is something very, I mean, you see where I'm kind of trying to go, right? I'm trying to like sell you a bit like based on this model, that this model is actually related to what actual monetary policy is doing, right? And I mean, this is not just Draghi, this is not just the ECB, right? The Fed is doing exactly the same, right? This is how actual policy making works. Right? Actually, the new Keynesian model has a problem. It also shows up sometime later in my slides. So you'll find lots of papers that are working on what we call the forward guidance puzzle. Actually, it turns out that in a new Keynesian model, forward guidance works a bit too well, right? Here, forward guidance, right? Like if you are a central bank, if you take the new Keynesian model at heart, forward guidance really is like the most effective thing you can do, right? It works so great that you don't have to worry about anything else, which is obviously also not true. Right? This is why many people have worked on kind of making that a bit more less extreme, and there's also like, I mean, ideas how this could be changed, but still I always think it's nice to understand that this model here gives you a very direct way to think about this, right? All right. So if you see papers about the forward guidance puzzle, this is what this is referring to. Okay. Good. So yeah, I mean, connecting the model to actual like events in the real world, right? So I'm here trying to give you another example, right? So I'm just giving you here a quote of Jerome Powell, who just gave us a Draghi quote, so this is kind of the other side of the ocean compared to that. So this is from August 2021, right? And this is important, right? So what did he say? So he said, right, I mean, policymakers and analysts generally believe that as long as the longer-term inflation expectations remain anchored, policy can and should look through temporary swings of inflation. Our monetary policy framework emphasizes that anchoring longer-term expectations at 2% is important for both maximum employment and price stability. We carefully monitor a wide range of indicators of longer-term inflation expectations. So I'm putting this quote because it actually gives you lots of these. First of all, it gives you lots of monetary policy terms. Right? It's like a very typical thing that you will see if you look at actually like monetary policy decisions. So maybe let's, do a bit like step by step, right? First of all, you see like this idea, like which is important for both maximum employment and price stability. This is what the Fed is concerned with, right? It's the mandate of the Fed to think about maximum employment and price stability, where we will say this is kind of remarkable because the ECB is first of all only concerned with price stability, but for the US Fed, this is actually like directly in the mandate to also think about employment, and this is why he's saying that, right? Okay, but that's not the major point that I wanted to make. I kind of wanted to flag a bit this term anchoring, right? You see that it shows up repeatedly in this quote. So what does that mean?
Basically gluing it hard so that it doesn't move, that expectations don't move at all.
Exactly, right? So by anchoring,
Putting so much weight or so much emphasis into this point.
yeah, exactly. That's also what they are trying here, right? So they're basically telling you inflation expectations are anchored. This is also why they hope they will stay anchored, right? This is a lot about communication, right? But maybe let's start from the first point, right? So anchoring in central bank policy means we are thinking about inflation expectations, in particular long-term inflation expectations. And this is also what he's saying here, right? As long as long-term inflation expectations remain anchored, and by anchored you mean they stay where they should be, and they should ideally be around 2%, right? So if a central bank has a target of inflation that's, let's say, 2%, inflation expectations also in the long term should represent that. So if you like go outside on the street and ask somebody, what do you expect will inflation be in, let's say, 10 years? That person should say 2%. That's the idea, right? That's long-term inflation expectations, right? Typically, they don't only ask people on the street, they will also ask people on financial markets, institutions, whatever, right? But how you actually measure this is a huge discussion, but that's the idea, right? You want everybody to believe that inflation will, in the long run, be at 2%. And this is what anchoring refers to, right? Why is that so important? Well, again, our new Keynesian model tells us a very clear story why this is important, right? You can either look here at this equation. Here I started off by saying that these long-term inflation expectations are at steady state. If long-term inflation expectations would become de-anchored, that's again one of these, right, monetary policy ways of saying that, meaning they move away from 2%, they're suddenly at 10%, this thing here would not be zero anymore, right? And then your inflation would go up, right, directly. Another way to see it is, if you don't like this infinite sum, would just go here. Here it's not so much the long-term inflation expectations, but all here, right? If inflation expectations go up, directly inflation goes up. So in a new Keynesian model, you really have like this one-to-one relationship between inflation expectations and inflation, right? And this is exactly what this here, or this here, represents. All right. What happened afterwards? Or maybe you can also frame the question a bit different. This is August 2021. Why was he stressing that so much? What was going on? But inflation was rising, right? At the time, inflation was rising. So why does he stress that so much? That's basically what you said, right? that was the time when the Fed, and I mean in that case Jerome Powell with the ECB was kind of doing a similar strategy, right? They were still trying to say, yeah, inflation is increasing, but this will all be temporary. I mean, you basically have this on this screen here, right? Your policy can and should look through temporary swings of inflation, swings in inflation, right? So that tells you at the time, the Fed, I don't know if they actually believed it or not, but what they were openly communicating was this increase in inflation that we've seen post-COVID was a temporary increase in inflation and we should not respond. That's what this quote is saying. And the argument that they make why they don't have to respond is exactly in this anchoring, is that they're saying the inflation, the long-term inflation expectations have not moved, right? So this is the argument that they typically give for why this is a temporary swing in inflation. So what happened afterwards?
Well, they responded, so they had to, because
Right. So these inflation, they became de-anchored. And that was then the moment when the Fed responded, and at some point also the ECB responded, right? And then, I mean, then they increased interest rates. But this was still before, right? And I'm kind of giving you here, like, this is really a quote, right, from one of these actually policy communications. The argument why would that they give? And I mean, you can basically understand that through the lens of this model. Okay. Further quotes. I mean, if you're interested, right? I mean, this is not US data. There's lots of publications, also Fed publications, looking, for example, at these long-term inflation expectations. Right? There's very different ways how this can be measured. It can be super interesting to look at this, right? And to try to understand how people actually perceive inflation. And this is actually a huge literature, right? Also an academic literature trying to understand expectation formation, because that really matters here, right? This is one of the big things that central bankers care about.
I have a question regarding the notation in the calculation. The steady state output, why don't we write it as steady state? Because if I remember correctly, the root thing is the change from steady state, but he's saying the output gap, this marks the deviation from steady state.
Yeah, you're right. And so what I do here, I'm actually defining this YF. I think I haven't talked about a lot about this YF, what that actually is, because it is kind of an abstract thing. So if you write down a new Keynesian model, you would not define the output gap as the deviation from steady state, but we typically define the output gap here as the deviation from what we call the flex price equilibrium of the economy. Now it gets ugly, and this is why I didn't talk about it a lot, right? So, here you have it, right? I mean, here's the definition, right? So this YTF is output if you were to switch off this Calvo price stickiness in the model. So if you say put theta to 0 and define output in your economy, what would it be? So we consider this as flex price equilibrium, or consider this as the equilibrium output that you would see if there were no price rigidities. And this is what, like, in this literature, we typically take as the benchmark for computing the output gap. So there's lots of theoretical arguments why we do this, because you can clearly define this, and this gives you a very clear understanding what we mean, right? It's also a bit related to, you want to understand, like, the role of this price setting friction, because that's what we're introducing here, and by defining these deviations, right? I mean, theoretically, the argument is very clear why we do this. Practically, obviously, nobody can measure this, right? I don't know what this is. I mean, this is a theoretical concept, but this is in the end true for any output gap measure that you may come up with, right? Also, if you define the output gas as a deviation from steady state, what is the steady state? I can also not observe that. Very often, like in applied work, you would define the output gap as deviations from what we call potential. Right? Have you seen that? I'd be really like the long run. What could the economy produce if there were no unemployment, if we are on like full employment, whatever, right? That's what we call potential. And this here is kind of a theoretical way to measure this. Yeah, I'm not sure this answers your question, but it's just a, right? So, I mean, in terms of your net notation, you're completely right. This is not the steady state in the model. And I mean, actually also this flex price, it also has a hat, because it does have a steady state too, and then we're also looking at the deviations from the steady state here. So that's it, right? So this will be important if you, in the RBC model, I talked a bit about efficiency, right? I said at some point in an RBC model, the model is efficient, right? And this is why you don't need policy intervention. This is the reason why we have this benchmark here, because this flex price improvement is also efficient, right? And you then basically, almost actually, and then you can go back to this benchmark and then really see how you can compare these two things. That's the reason why this is typically defined in these models. Okay. That was this, right? So there's, I mean, we were talking about inflation, what's driving inflation. There's actually one thing that you did not say yet, which is nice because it's not coming on my slide. Is there a role for fiscal policy for inflation? What do you think?
Yeah, well, if we've got expensive fiscal policy, then we've got more money coming into the market, increasing the amount of money.
Exactly, right? I mean, that would already be true in an ASAD model, right? If you have expansionary fiscal policy, you're generating demand, and that would at some point increase prices and generate inflation, right? There's actually many more arguments in the literature around, right? There's an argument about government debt, right? Is it that high government debt generates inflation? And that's kind of where I want to go a bit, what I want to show you, right? Because for that you actually don't really need a lot. And that's kind of what I want to show you once, right? Because I mean, again, this is I think one of these examples where I want to show you that I'm not showing you models here to put some kind of paradigm into you, right? I'm basically showing you models to show you what you can do with all of this and what you can actually think about. And this is also one thing you can very easily think about, right? Okay, so what I do on this slide is to say, okay, let's introduce a government, right? What would be a government here? That's an institution that has government spending, right? Our GT, you've seen that before. And this GT has to be financed somehow. And we have this typical idea, this can be financed in two ways. You basically have government debt here, for example, right? So governments can take up debt, right? For that you have to pay a nominal interest rate. I think that makes sense, right? And then what we typically do is to write down a government budget constraint. And if you look at this budget constraint, there's actually one thing that I do here that I have not done on earlier slides where I talked about government spending. What's different compared to what I did before? Is there something maybe that you find? Or maybe just look at the equation. What's the interpretation of this equation? What do you see? It's the government budget constraints, but what does it tell you here?
Maybe that it is normalized by the price level.
Yeah. True. It's all in real terms. That's important. Exactly. This is why I'm dividing everything by PT, right? So I mean, T is taxes, right? That's government income. So,
I mean, we have M right now, so the overall amount of money.
yeah, exactly.
And
Right?
here we are checking how M changes over time.
Exactly. That's the new term here. We didn't have that before, right? This is kind of the most general version how you can define a budget constraint. So what this here tells you is that this is if you want government income, you get income from taxes. You get income if you like issue more debt, right? And you get income as a government if you print money. That is this term, right? The change in money supply and in real money supply, as you were just pointing out, right? I'm dividing everything by PT, right? This is what we typically call sign rush. Right? So this is really this idea that in principle, right, your central bank could directly finance your government. Very often we don't have this term, right, if we write down government budget constraints, because we say in our world we believe these two guys are independent, our central banks don't do this, but obviously they could, right? And here I'm taking this into account, right? So this is income of the government. This here is spending of the government. So what am I spending? I'm buying goods, that's GT, and I'm repaying my debt from the last period, right? Including interest, that's why the I is showing up here.
I have a question. Why the tax and government spending don't divide it by price?
Because I'm defining that here in real terms. You could also define it in nominal terms and then it would be divided by P. That's it's completely up to how you want to write it down. Okay. So that's what I do, right? I'm defining government budget constraint here now in the most general form by also taking into account that my central bank could finance the government, right? With this change in the money supply here, right? So now, I mean, in the interest of time, I mean, you do some rewriting, but what you have to do is really just take this equation 8, and I mean, again, this equation 8, we say this is an accounting identity, right? For equation 8, I'm not putting in any model. I'm basically not putting in any assumptions. It's really like just writing down the budget constraint, right? And I mean, it just tells you spending equals income. That's what it's saying, right? So now you rewrite this, and I mean, you do some stuff, but what you will end up with is an equation that looks like this. And I will just give you the idea, and I will maybe get back there after the break, but just to show you where I want to go, right? You can write this equation and solve it for the current level of public debt, and I mean here it's the real level of public debt, right? And this term basically tells you that this real level of public debt has to be financed in a certain way, and it has to be financed basically by the future income stream of the government, which is discounted. This is why the real interest rate here shows up. And this future income streams depends on your surpluses, right? T minus G is the government surplus. How much taxes do you have coming in? How much does the government spend each period? Or it has to be financed by money changing, which is, according to the quantity theory, labeled inflation, right? So this guy here relates directly to inflation, right? So this term tells you you can finance your current spending, government debt, the current government debt, either by running future surpluses, which is basically autarky in the future, if you want so, right? Or by printing money and generating inflation, right? And now the question is, does it tell us something about what determines inflation, right? Because that was actually where I wanted to go, right? Does that also mean that government debt determines inflation? And you can put the whole thing around and then say, yes, maybe it does, right? Let's come up with a situation where government debt is pretty high, and the government is not, for whatever reason, running these surpluses or committing to running these surpluses in the future. Then the central bank has to go in. That's what this equation tells you, right? And this is what the literature calls fiscal dominance, right? Then you're running in a situation where your central bank is financing government debt by inflation, right? You're basically deflating away the government debt, right, by inflation, right? You're generating inflation. And I mean, this is something that central bankers also really worry about a lot. Normally, we don't want to be in that situation, right? Because that means we're giving up independent monetary policy. That's what it means, right? You're giving up independent monetary policy. Normally, you want to be in a state of what we call monetary dominance, right? If your government is behaving, then the central bank can control this guy and can do its job, right? That's what you want to have. But it can happen that this whole thing switches, if you want so, right? And that's what we would call a regime of fiscal dominance. Right? So let's have a short break, and I give you this here to think about. What do you think? What's the regime that we're currently in? And while I think about this, you can have a short break and do some sports. Brüste ohne Ellbogen. Noch 2. Und dann einmal loslassen, Arme vor den Körper. Wir stellen uns vor, wir rudern zusammen, ein Ruderboot, wir ziehen kräftig zur Brust und strecken die Arme wieder vor. Und Zug, strecken, Zug, strecken. Aber schön aufrecht, nicht zusammenfallen, genau. Kräftig hinter den Rücken ziehen, die Ellbogen. Und noch 3, 2, 1, lösen. Und wenn das so passt, jede Seite, legen wir mal die Hände hinter den Körper und dann legen wir mit dem Oberkörper nach vorne, versuchen die gestreckten Arme so hoch wie möglich Richtung Decke zu halten. Ja, genau. Wenn ihr den Oberkörper maximal vorne seid, dann versuchen die Arme noch etwas anzulesen und die Dehnung zu halten. Halten, 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 halten und langsam wieder aufrichten und die Arme ausschütteln. Und zum Schluss dehnen wir noch einmal den Unterarm. Die Hand nach oben ziehen und das noch verändern, dass wir die Hand nach innen drehen und einmal nach unten. Jetzt können wir schön die Finger mit nach unten, ja, dann sind die auch verspannt, genau, unten dehnen und auch mal nach außen ziehen und Handwechsel, einmal Hand nach oben. Nach innen. Ja, unten, Daumen auf den Handrücken und außen. Nochmal locker und zum Schluss rühren nochmal die Faust nach innen und die Armaußenseite, die Unterarmaußenseite einmal zu drehen, gestreckte Arm, Faust mit der anderen Faust beschließen und nach innen eindrehen. Ja. Und das Ganze nochmal auf der anderen Seite. Einen kleinen Moment halten und dann locker lassen und weitermachen bis nächste Woche. So what do you think? What regime do we have? Are we under fiscal dominance or are we under monetary dominance? Situation because we had, right, I mean, after because of the Russian invasion of Ukraine, we had rising energy pricing. That was a huge issue here, which is obviously contributing a lot to inflation. In the US, that argument was not so much there, right? Maybe not as much, right? For them, this argument was very strong, right? Is it actually maybe not loose monetary policy or whatever supply chains creating inflationary pressure, but is it that? Many people make that argument, right? That we are like entering, or that the US is entering a regime of fiscal dominance. I don't know, what do you think? This is never a 0-1, right? I mean, nobody can tell you for sure. We are now in regime A and now we are in regime B, right? I mean, this is impossible, right? But again, this is like theoretical constructs, but they should mean something to us, right? So what we will find is lots of publications. For example, there was a famous speech by Janet Yellen. She made the point pretty clearly that she really sees the danger of the US entering a regime of fiscal dominance, right? Which basically means you're giving up your monetary policy independence, which means you're giving up your control of inflation. Right? That's basically what it means. And that was even pre-Trump. Right? If you want.
Because obviously the central bank has to react with new economic events. But that's not fiscal dominance yet. Fiscal dominance would be the government being like, oh, we'll take as much debt
Yeah.
Because we force the central bank.
Yeah, so this is not something where you would say, right, under COVID, the governments are increasing debt, and this is necessarily imply fiscal dominance. It would only imply fiscal dominance if, like, this, in the end, this is also about expectations, right? I mean, here's no expectations here, but this is about the future stream, right, of government surpluses. So the question is, does your government make the impression that the future surpluses that it will run, and I mean, this can be in 20 years, right? It doesn't have to be today, right? And there could be in 20 years that they will actually finance the current level of debt, right? And I mean, that's like, I would say, like, for example, if you think about Europe, what do you think? Are we in a system of monetary or fiscal dominance? Look at Germany, I don't know, Germany, pick whatever country you like, but
I think it's not black or white, but it was mostly monetary dominance. But I think through all the crisis situations, it's tending towards fiscal dominance because Germany is also more in debt than 10 years ago.
yeah, that's true. But I would say, like for Europe, I think the argument is not as strong as for the US. It depends a bit on the country you look at. France may be different. But if you look at Germany, let's say, right, I think we generally believe that this year is doing a good job, right? And because of that, this is okay, right? Okay, it's also, you could also make arguments and maybe say, well, fiscal dominance is great, right? Just saying under fiscal dominance, you really give up the control of inflation, right? And then inflation will be determined by government. Okay? And I mean, obviously inflation means something for your consumers, right? And I mean, that's then something which is then not controlled anymore by the central bank, right? So that's the way to frame it, right? All right. But this clearly was, I mean, or is part of the discussion that we are having with the US. And I mean, there are some people who said maybe also like for some European countries this may also become an issue. Right? Right. Maybe another way to think about it, that you probably know these discussions about zero level bound. Right? I mean, we do say if the zero level bound, monetary policy loses its power, right? And then we have to think about unconventional monetary policy, whatever, right? In a way, this is another example where if you are under fiscal dominance, monetary policy loses the control of inflation, right? Maybe that's the way to say it.
Just for fiscal dominance, if in Europe, like, there are just a few countries that have this problem with too high debt, like Denmark, for example. I mean, it would still affect all the others, like Germany as well, because the central bank has to save France, and this goes into
And this is part of the ECB, they're quite alive, right? I mean, this is exactly why they do this, right? Why the ECB, they try so hard to control these spreads between governments, treasuries, inside of Europe, and that's what makes their job so hard, right? I mean, it's basically this point of we have a common monetary policy, but we don't have a common fiscal policy, which makes this issue even much more difficult, right? But then, in a way, these Eurobonds is a simple way to solve this.
Okay, but so right now you could say that if one country is in danger of fiscal dominance, all basically are also they are doing fine.
Yeah, in the end, it depends on whether people believe that the other countries would cover these surpluses, right? I wouldn't yet call it a bailout, but if you would like say, I believe that the European Union as a whole takes care of this, then it would not be a problem. But if you do not believe this, and then it's also a story about political stability and stuff, right? Then it would be different. Very good point.
Is fiscal dominance inherently bad? If you say you control the inflation cost by giving more less debt or something?
The question is whether you believe your government would do this, right?
Yes.
I don't know. Right? I mean, like, history tells us a bit that if governments are highly indebted, they will deflate this away at some point. And I mean, inflation means something for, say, your consumers, right? I mean, that means that the government is spending more money, but basically on the cost of the consumers in the economy. Which, I mean, inflation has all kind of effects, right? And I mean, this is another. Now I'm opening up even more stuff, right? I mean, is inflation good or bad? I don't know. What do you think? Do you like inflation or not? That's actually very interesting. You typically, like, if you look at surveys, people typically always say they don't like inflation. Actually, economics models are not always so clear. There's a lot. I mean, also like, just think about. I mean, the ECB has a 2% inflation target, right? We don't have a 0 inflation target. So there is actually some positive in inflation too, right? We know this. There's economic arguments for inflation, but it should be controlled, right? And here always the point is, if it's not under control, then it becomes a problem.
I have a question about this end terms. What exactly is the things that actually all contribute to this? Is it also the ECB printing money and buying government bonds? Does it also contribute to that?
Yeah, that's basic. I mean, here not directly, right? Because here it's the government bond here is bought, but it's not. But in principle, yes, yeah. Here it's really like this idea that, I mean, you also have that, right? If your central bank makes profits, these profits are going to the government. This is true, right? I mean, this is what happens. So maybe that's the way to think about it here, right? But yeah, in principle, yes, right? I mean, the central bank, I said I'm not doing many assumptions here. Obviously, I do assumptions, right? They are also controlling that guy, right? Not 100%, but obviously the interest rate is, that's what we just said, right? I mean, this is why the ECB is looking at all the spreads. It's never as simple, right? but it's there, yeah. I mean, I was just like, I didn't like go through all the math, right? But it just, I mean, basically what you have on this slide is really just showing you, it's really just rewriting this budget constraint, right? And then you again make this argument that you can basically rewrite here, like, I mean, this is an iterative term, my current debt depends on future debt. This is coming from here, right? Because basically what you like, the current debt level, I mean, you have to repay your debt from yesterday, right? This is why this becomes iterative. And then you make this an infinite sum again. You've seen that before, right? I mean, like in terms of the math is pretty much always the same. And then I'm discounting a bit, and this is how this equation falls out. Right? Okay. Questions? That was a bit of a part in between where I kind of tried to use this model bit to talk a bit about actual inflation and actual monetary policy. Because I mean, these are these discussions that we are having, right? I mean, I always know like these macro one course is a lot of first order conditions, but in the end, there's a reason why we do this, right? To discuss all this stuff. Okay. Now I don't want to go back to first order conditions, but I want to go back here. So what I actually have not shown you yet is actual impulse responses in the New Keynesian model, right? So far, I've used the model and some of the model equations to give you a bit of thoughts about inflation, which I think is also interesting. But now I want to basically go back to what we did with the RBC model, to calibrate, to solve the model, and to actually see what shocks do the model do and how they affect the economy. So part of this here is now also showing you that like what I like spent some time in the RBC model talking about, right? How we actually solve this, the method of undetermined coefficients and all this. You would just do exactly the same stuff here. I'm not showing you all of this now because this would take us a long time, right? But I'm just like want to tell you what you did there, what you studied there is exactly what you need now again, right? Because this model, I mean, here I already showed you the log linearized version, right? In principle, you know how to get there, right? You know how this can be obtained, right? From the first order conditions, you would do the same here. And then you have exactly the same problem. This is a dynamic model, right? Current inflation depends on future inflation. Output depends on future inflation. Right, so you have, this is all interacted, right? Here current output depends on future output. Expectations matter, the future matters. This is a dynamic system, you need to solve this. Right, just as in the RBC, exactly the same problem. So we use exactly the same methods to solve it. Right? Actually, I think what I will show you here later, I mean, I will show you IRFs in a second, right? These now come from Dynar, right? So here I did not construct them with Excel. You can do that with this three equation you came in, you can if you want. It's not like this model would be too large for that. But here I'm just using, right, I mean, as I said, Dynar, which is basically one of these programs which runs very smoothly to do this. And again, I mean, I was just saying that earlier, right? I mean, this is all the stuff that I do in summer, right? In the current macro, we will do exactly this. I'll show you this in more detail. For now, let's just take the result, right? Okay. So we want to solve the model quantitatively. If you want to do this quantitatively, you need numbers first. We need to calibrate the whole thing, right? This is my calibration table here. I think some of the stuff will look familiar to you, right? Because some of the variables are just, some of the parameters are just the same as we had in the RBC, right? So there is a discount factor, for example. The discount factor here, I set at 2.99. We already discussed why this makes sense. Here you can take exactly the same argument, right? We have risk aversion here. I'm setting that to 2, which is also a very typical value that you find in the literature. We have this labor supply elasticity, which is also playing some role here, right? I'm setting that to 2. And you also have here, I will also show you a productivity shock, right? So a shock to aggregate productivity in this model. And we're calibrating that here basically in the same way as we did in the RBC. So where you have this autoregressive parameter and I have some kind of here standard deviation in that case to that shock, right? So this is the shock to A. And then there are now some parameters that we had not seen before. So there's first of all this elasticity of substitution. This is this epsilon, right? So this guy that determines basically the market power in the economy. How easy is it to substitute good A with good B, right? Remember that I showed you when we derived the firm problem that this parameter determines this price markup. Right, that was this equation where I showed you price is higher than marginal cost, and in between was this markup, epsilon over epsilon minus 1. This is exactly what we use for calibrating this epsilon, right? Because I mean, what do I know? What is like this elasticity of substitution I cannot measure, right? But price markups, there is actually ways to measure this, right? So if you go into the micro literature, the whole literature trying to estimate this, because it also gives you some idea of how close are we to, or how far away are we from perfect competition in certain industries and whatever, right? So this is stuff you can do. And this is what we would be used here, right? And I mean, don't nail me down on the exact number, right? But this is a common number. We say, okay, we find markups of around 11%. And this implies that we set this epsilon to 10, right? And I mean, as always, right? This is now all in the numbers. If you don't like 10, try 15 and see what changes, right? So this is something which you can very easily do with these models. Another parameter which is new that we have not seen in the RBC is this Calvo one, right? So this theta was this probability of not adjusting prices. We typically set that to something like 0.75, maybe 0.80. This is common values that you see. And again, for that we look into microdata. I actually showed you the data at the beginning, right? So we actually really look at how often do firms adjust prices. And you very often find like this price duration between 3 to 4 quarters. And this is basically what matches that here. Actually, that parameter is important in these models. So it actually makes some difference how sticky prices are, okay? These two parameters are also new. This is phi y and phi pi. This is the coefficients that we were setting in the Taylor rule. Maybe let me show once again because I didn't talk about it for too long, right? So in this Taylor rule, right, you have this idea the central bank sets the nominal interest rate and it looks at the current level of inflation and the current level of output, right? And the weights that it sets on inflation and output, that's these phi coefficients. Right? If phi pi is high, then you would have a very aggressive monetary policy, right? If inflation increases, they would respond very strongly with increasing the nominal interest rate, right? If it's rather moderate or low, you have a central bank which is maybe doing more, where is it, more this, right? So we're just looking through this. Okay, good. So that's these two parameters, right? And I mean, this again, there's a whole literature trying to estimate that from data. I'm just throwing 2 parameters now at you, but this is typical values that you see in the literature. So for example, this implies that central banks respond more to inflation compared to output, which I think makes sense, right? Because that's their overall concern, right? To control price level. This is why you see this. And what is new is this rho m and sigma m. This is also related to my shock processes. I said when we derived the model that we have one new shock now, which is the monetary policy shock, the shock on the Taylor rule. I think I called this, what did I call this, V? Yeah, that guy, right? And for that, I'm also specifying an autoregressive process of order 1, and I mean, that's just what I define here now, right? How autoregressive is that, and what's the standard deviation? And that's these 2 formulas. Questions? Otherwise, it's just numbers so far, right? So now what we do? Basically, right again, but what I'm sparing you now is this whole issue how to solve the model, right? Basically, if you want to understand what we do, take our RBC chapter and see like all the discussion that we were doing about how we solve this. I'm doing exactly the same thing now, right? In the RBC chapter, at some point then we ended up with a figure that looked somewhat like this, not exactly like this, and we will be discussing exactly now what's different, right? But I'm looking now at the impulse responses to a technology shock, right? So I mean, all the arguments that I made before was basically always I was trying to look at, let's say, just looking at the new Keynesian-Phillips curve and making an argument about what's driving inflation, right? But I was just looking at the new Keynesian-Phillips curve. So I was just looking on the firm side, I was just looking at supply. I did not talk about demand much, right? In these impulse responses, I take all of these 3 equations at once, right? So that means, you know, the impulse response, this is a productivity shock, you will have firms responding, then you have households responding, then you have firms responding again, you will have monetary policy responding, right? So that's the reason why we have impulse responses, right? You're not just looking at one agent or one market, but we're looking at the interactions of all of these. And I mean, repeating myself, that's macro, right? So we're doing all this stuff at the same time, right? And that's the reason why we have these RAS, because they represent those. Okay, so this is now a positive technology or productivity shock, right? So you're basically, I'm starting with that on purpose because you can basically put this figure next to the figure that you've seen in the RBC model, right? Also in the RBC, we studied the effects of a positive productivity shock. Okay, well, so what can you see here? This black line, this is productivity. Productivity goes up, right? This should not surprise you. That's what we defined here, right? Positive productivity shock. And then it decreases slowly over time. That's this autoregressive process that I specified, right? This is this autocorrelation of 0.9, right? So the shock is, we would say, very persistent, right? It takes until more than 20 quarters, right? Even after 20 quarters, productivity is still higher compared to steady state. Right? So what happens now in your economy? Oh, I mean, there's multiple figures coming now, right? Because the story in the new Keynesian model is, there's many things coming, but I hope I get it across, right? So maybe focus on the blue one first, right? What is the blue one? The blue one is output, right? So that's GDP in your economy. So what this tells you, output increases, but it increases less than the productivity shock, right? And it also increases, but it increases less than what we call the flexible price equilibrium, right? And that's exactly what your earlier question went up to. You were asking about, right, what is this flexible price equilibrium? What is this output gap definition here? Well, in these models, the output gap is defined relative to this flex price equilibrium. And what happens after positive technology shock is that the output gap actually falls. Why is that? Well, because, I mean, in a flexible price world, people would basically be producing immediately as much here, right? Prices would go up, you would see GDP increasing with productivity pretty much 1 to 1. Right? Here, this does not happen, but output increases by less compared to the increase in productivity, which means we're running in a negative output gap. And one way to interpret this is to say, yeah, that is because demand is not sufficient in this economy. There is now a demand effect coming in, and this is something that you don't have in an RBC model, right? This is particular to the new Keynesian one, right? And what's the reason? Well, that's the sticky prices, right? I mean, it must be the sticky prices because that's the major change. But basically what's happening here is you increase productivity, firms can produce more, right? This will decrease their marginal cost of production, right? Productivity has gone up. They can produce cheaper than they did before, right? They should decrease prices, right? Another way to think about it is to say, you have productivity going up, supply goes up, right? They're producing more, these firms. But demand does not go up, right? Supply is higher than demand. So what you need is a drop in prices, right? To equalize supply and demand, right? If the prices fall, then demand would go up, and you would see an equilibrium again, right? But here, prices are sticky, right? Some firms will reduce prices, but not all of them, right? And this is why demand does not go up enough, right? So this is why this model here basically tells you something about missing demand, right? And this is, again, what's, I said at the very beginning, what is Keynesian in these models? This is Keynesian in these models, right? So demand actually plays a role here, right? GDP is lower than it would be without sticky prices. Okay. You can actually see this if you look at inflation, right? So here on the next slide, the black line, this is inflation. Inflation falls. Right, that's this decrease in prices, right? Productivity has gone up, everything becomes cheaper, firms decrease prices, but they're not decreasing as much as they should. So this blue line here I'm plotting optimal inflation. So that was the variable that I named pi star at some point on my slides, right? Where I said that would be that's the level of inflation that firms set if they are allowed to adjust prices. So like the desired level of the price level, but not all of them are allowed to, right? And you basically see this huge difference, right? And this is completely driven by this beta parameter, right? And this is then the reason why consumption doesn't go up enough, right? In the new Keynesian model, you would be arguing via the Euler equation, right? So demand happens or works via the Euler equation. So what you need for demand to go up, if you want consumption to go up, you need that the real interest rate falls, right? If the real interest rate falls, people will consume more. They save less, consume more. Here, the real interest rate I'm plotting, and yeah, that's the yellow line. It does fall a bit, but it doesn't fall enough as it should, right? And again, the reason is the prices, right? I mean, the real interest rate is driven by the nominal interest rate and inflation doesn't fall enough. This basically generates upward pressure on the real exchange, the real interest rate. Exactly. Right. Right. So why does R fall here? Well, because the central bank is intervening, right? I mean, as I said, this is three sides of the economy here all intertwined, right? So you have productivity, you have firms responding, then you have households responding to that, and the central bank will respond too. What does the central bank do? Well, I mean, the central bank sees that in equilibrium we have output going up and you have inflation falling, right? So what it should do, and I mean, that now depends on your Taylor rule, right? Where's my Taylor rule? Sorry. So the central bank sees inflation going up, inflation falling, the output gap going up. So then depends on your coefficients, but as I said, the coefficient of inflation is typically larger, right? So this effect here is weighted more strongly. So it will respond to this decrease in inflation by lowering the interest rate. And this is exactly what you can see here in the nominal interest rate that falls. But the real interest rate falls less because inflation falls too. Right? Okay. You can also look at the labor side of the economy, right? I mean, you have wages in your model, you have hours worked in the model. And here what you can see, I mean, you see first of all these marginal costs of production, I'm plotting them here, they fall. This is really just because productivity has increased, right? Yes, and for some reason, everybody's more productive, this directly decreases your cost of producing, right? That's what you can see here, right? This would actually imply that the real wages would increase, right? I mean, if productivity goes up, this should feed into the wage, right? Higher wages, higher productivity, higher wages. This is also happening here, right? Real wages do go up, but basically they are not going up by enough here. And this is again related to the prices, right? Not falling enough and so on and so forth, right? So you would see here, if you would plot them, that markups increase. So there's this reflation story here, right? Firms increase profits, right? These profits are then distributed to the households, and now comes one of the nicest predictions of the new Keynesian model, right? If you have profits going up, firms have higher profits, but they're redistributing that to the households. So what do households do? They have a higher income, right? So what these guys will do, they will work less, right? And this is why you see in this model that hours worked fall, right? Which is the opposite to the RBC model, right? In an RBC model, hours worked actually increase after a positive productivity shock, right? Basically, everyone's trying to exploit this higher productivity. You know, it's temporary, so that's why you really want to work more today. There was this intertemporal elasticity of substitution argument. Here, you have, I suddenly get higher profits, right? Because these firms are making profits now, because not all prices fall enough, right? So let's just work a bit less, right? That's what's happening here, right? And this wasn't, I mean, there's, the new Keynesian model is like, I mean, comes like in this basic form, comes like from the 90s, I would say, right? This used to be one of the major arguments, well, for the people that were pushing the new Keynesian model. They were saying, this is what you see in the data. Obviously, it's not so easy to disentangle this in the data, but there's ways to do this. And this was, like, at the time, one of the major arguments where people said the RBC is nonsense. It's all this new Keynesian type of models. Because this only matches the labor supply or labor responds better. If you ask me, I would say most of them are not doing a very good job here because they're not modeling the labor market better. In the 90s, there was a big argument, exactly this one. Okay. So, I mean, long story short, right? I know these IRS always with much stuff happening here at the same time, right? But a positive technology shock, so A going up, higher productivity, your GDP increases, right? This is happening here. GDP increases, you would also see consumption increasing, right? So if you, I haven't plotted consumption here, but consumption would also go up, right? So people would be better off. They're consuming more, they're actually working less, right? If you think about the utility function, that's great, right? So they like this. But consumption does not go up as much, so demand does not go up as much as it could because prices don't fall enough and prices are sticky here, right? And this is basically what's generating here in this effect that the output effect is smaller than it could be. Okay.
Is there a reason why hours worked and the inflation at the same number?
There probably is a reason here. I mean, it must be somewhere in the calibration. I don't think there's an economic reason. Yeah, I mean, I was already saying, I try to compare that a bit to what we discussed in the RBC model, right? In the RBC model, we are basically looking at the flexible price equilibrium, right? In the RBC model, we are in principle looking at this number that you asked for earlier, right? This YF, right? Because in an RBC, you don't have this price stickiness, right? It's actually not 100% true because there's also monopolistic competition, but let's take it for that right now, right? And I mean, we discussed that the RBC model is efficient, right? So in an RBC world, the business cycle is completely driven by productivity. You need no policy intervention, everything's efficient, right? Here this is not the case, right? So like this negative output gap that you would see is inefficient, right? So basically, I mean, that's what I showed you here, right? Output does not increase as much as it could here, right? So let's say productivity increases, I don't know, let me just make up some numbers, by 3%. Let's say by 6%, right? Or by 8%, 10. Okay, let's say productivity increases by 10%, right? This figure will tell you output only increases by 6%, right? So this model tells you, yes, GDP goes up, but does not go up by as much as it could. And that's what we call inefficient, right? So then a natural question to ask would be, could policy now intervene to make this outcome better? What could it do?
Decrease the interest rate?
Yeah, exactly, right? So if the central bank were to, where's my interest rate here, the blue one, were to decrease that guy much more strongly, you would create more demand, right? Think about the Euler equation, people would consume more, and you could basically increase output here, right? So this is already one of the reasons for basically saying, in this model, the world is not efficient, so there is an argument for policy intervention, right? And again, this is kind of in this Keynesian style of arguments, right? That we make. Policy can actually, I mean, here would not be stabilizing because we're thinking about a productivity shock here, but still could get you closer to the efficient outcome in the time. Okay. But it would do so by generating inflation, deflation in this case, right? So these trade-offs are also there. The New Keynesian model is actually rich enough that you can put in many shocks, right? I mean, with the RBC model, I said at some point that this is one of these typical criticisms, right? In an RBC world, everything's just driven by productivity. Here, you can think about all kinds of things which are driving your business cycle, right? I mean, remember, that's actually why we developed this whole model, right? When I think about a business cycle, right? This here is a business cycle, right? You have GDP increasing, right? With positive productivity. You can here now also look at monetary policy shocks. You could here also look at demand shocks, right? You could do something to your households. You could introduce a government. That's actually what I will show you, not today, but the next week, where you would again be introducing fiscal policy in those models, see what's happening, right? And it will actually be very different to what you see in an RBC, right? Okay. So this here is now a positive monetary policy shock. I'm not sure whether this is the best way to frame it. That's actually what I realized when I looked at this slide. So what I'm doing here is I'm increasing the nominal interest rate, right? So I mean, you have it in the words, right? But the central bank increases the nominal interest rate, right? And I mean, the way to think about this, sorry for jumping, but just to show you once to make sure that this is clear, right? So we have a positive shock to this guy. Right, so that's the guy that increases, but I mean basically on impact, if this guy is not changing that, that means directly that the nominal interest rate goes up. Right, that's what we're looking at. Okay, so an increase in the nominal interest rate, and now you can look at what does it do, right? Remember, an RBC model would not do anything, right? In an RBC, you would just see flat lines. Here you suddenly see something happening, right? So what's happening? I mean, here, first of all, you see that the real interest rate will also rise because prices are sticky, right? That's the major argument that you need. In an RBC, if you see an increase in the nominal interest rate, inflation would increase immediately and the real interest rate would stay constant. Here, the real interest rate does also rise because prices are sticky and they're not increasing one-to-one. That was the whole reason why we introduced that, right? An increase in the real interest rate means that people save more and consume less, right? So you're reducing demand, right? You're reducing consumption, so here, that's what you have here, right? You're raising the real interest rate, and this implies that consumption falls, right? You're reducing consumption. Consumption is the right main determinant here of aggregate demand. This means that inflation will also fall, right? Demand is falling, firms will basically follow, but they cannot follow one-to-one because of this price stickiness, right? I mean, see the argument, right? I'm going in circles, but that's what we said from the beginning, right? So you also see inflation falling, right? And I mean, once demand falls, also output will fall, right? And you see that inflation falls, right? You basically have it, right? You would also see that labor demand drops, so hours of work drops, and wages fall. But that's basically all that's what we said before. Important message is you do see now that this shock to monetary policy, in this case a positive shock, right, which increases the interest rates, reduces inflation and reduces output. Output is here. Here's output. It's actually hidden here, so the graph is not very nice. So the output response is also here. Right, that's output. Right? So output falls, whereas the price level and inflation also falls. Okay. And by that, you have this result now that monetary policy can actually affect the economy. It can affect your business cycle. It can even create business cycles, right, if you want so. I mean, that's what we're having, all this discussion, does monetary policy actually do this or not, to what extent, right? But you have here this idea that, I mean, this here would be contractionary monetary policy, right? An increase in the interest rate reduces demand, reduces inflation, and by that reduces GDP. Right? That's what this model can get you. Questions?
You're using a much lower stochastic parameter here, right? So this
Exactly, yeah, very good, yeah. So if you wonder why the effect of the monetary policy shock they are short-lived, right? After 4 quarters, everything's over. With the productivity shock, the effect lasts much longer, right? I mean, this is a matter of this autoregressive coefficient that I put in here, right? Productivity shocks last for a very long period, the monetary policy one not so much, and this is why the effect is much more short-lived. Actually, a typical calibration of a monetary policy shock would be even lower, right? So these are typically not so autocorrelated, right? Because I mean, these are policy decisions. There's a bit more randomness involved compared to a productivity shock. The reason why I set it to 0.2 is I actually had it lower at the beginning, but then it was even more impossible to see something on the figure. That's why I've increased it a bit to at least be able to show you a bit here, right?